right, so we're going to come in for our second set, 6 through 10 of our questions. So, we're going to jump right in. Would scientist 3 agree with the statement that earthquake light is made of electric arcs? So I'm going to go to here. This says earthquake light is a result of collisions between electromagnetically accelerated particles. All right. Electric fields generated, blah, 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 constantly changing. These changing electric fields produce magnetic fields, which in the influence of motion, right here, I never see the word arcs. So, let's go through there. What do we think is happening here? Now, we're going to decide on our answers here. Collisions between high energy airborne particles, So, I never saw the word arcs, so I'm going to go with no. Now, no, because SiO2 does not produce piezoelectricity, or no, because collisions between accelerated particles produce photons. Which answer are we going to here? So, this one, let's look for the words. SiO2, electric fields generated by the piezoelectric. So we do see that one. So we see that key term. So that doesn't match with does not. And this says collisions between electromagnetically accelerated particles, and then photons are observed. So I can find all of the key terms. So my answer is D. Number 7, would scientist 2 agree with the prediction that large amounts of small grain particles will be found near sites of large earthquakes? Scientist 2. Refraction of light, crystalline particles. When light enters a crystal, different wavelengths. Powerful earthquakes produce very fine particles, which are propelled into the air. Once airborne, they refract light. If earthquake lights were made of electric arcs, their durations would be very short. So, right here, large amounts of small grain particles. So he talks about small grain particles a lot. So that is going to be something that is going to make this a yes answer. Now let's decide. Earthquakes pulverize minerals but do not launch them into the air. We read that it launches them. And then dust particles launched in the air will eventually fall back down to Earth. So yes, here, because then it says, earthquakes propel them into the air. What goes up must come down. Right there. All right. Number 8. Would scientist 1 agree with the statement that areas containing abnormally low amounts of SiO2 and higher amounts of non-piezoelectric minerals are less likely to have displays of earthquake light during an earthquake? So let's go here. We need to look for the words SiO2 and piezo or piezoelectric. Doesn't really matter how you say it. You don't have to know what it means. Earthquake light is produced by piezoelectricity, so that's one of our buzzwords. Electric charges, mechanical stress. Areas affected, mechanical stress. Earth contains SiO2. Earth's crust contains over 70%. Much of the crust will have some response. During an earthquake, the response can be power enough to produce visible electric arcs, like lightning during a thunderstorm. Okay, so areas containing abnormally low amounts of SiO2 and higher amounts of non-piezo are less likely to have displays. So what this one is saying is it's 70% SiO2. That's high SiO2, and that's why we have the the electric arcs. So that's going to be a yes question, because if he's saying high SiO2, high earthquake arcs, that means that low SiO2 would be no light. So SiO2 is the most abundant contributor of piezoelectric response, or yes, only pure crystals produce piezoelectricity under mechanical stress. So it doesn't say anything about it having to be pure. So the correct answer here is A, because the word pure is not present. All right, and then we're just going to go over 9 and 10, which have to do with the different scientists. So, number 9, according to scientist A, is it reasonable to hypothesize that the IRA might be found in kidney cells? So, scientist A, IRA in kidney cells. That's what we're looking for. The IRA, new organelle, and we're just skimming through this. Similar structures, germ cells, pancreatic cells, other staining procedures, have been used to replicate these results. The appearance of the IRA change according to the activity level. Although it's too early, it may play a role in cellular nutrition or secretion. So, if we go to number 9, I'm going to say yes because it talks about other cells it can be present in, and let's look here. So, can you guess that it might be in other cells? And the answer here is going to be A, because they say in here, similar structures, this is the quote that you would put, have been found in other cells. So it could be in any cell because we've found it before. And number 10, would scientists A, disagree with the statement that IRA consists of protoplasm? So, net-like structures are a new organelle. This organelle is suspended in the cell's liquid protoplasm. Silver bonds with the IRA, but not the protoplasm, which darken it. So, right here, we're going to say yes because it mentions protoplasm twice. So, this is 2 times in the passage. Now, yes, because silver ions do not bond to the protoplasm. That has nothing to do with the IRA. It just says what it doesn't do. So yes, because the IRA is in the protoplasm. So it says in this sentence that it's suspended in the protoplasm, so that's our answer.